Graphing radical functions. So first we're going to talk about the parent function. So when I'm graphing this, we're going to go over a couple of things. So if I go to my y equals, I'm going to clear that out. This is my parent function. So the second and then x squared to get my square root, and then that button right there to get your x. I'm going to push graph. I'm going to actually go to zoom and push 6. So I'm in that 10 by 10 grid. This is what my parent function looks like. Now there's a couple of things here. Why don't we have anything over here? Because we can't take the square root of a negative. So we're not ever going to have anything over here, right? Why don't we have anything down below is because when you take a square root, it needs to be a positive number because this number has to be positive. We're not going to be dealing with imaginary numbers. So my parent function, if I want to go into the table, so if I go second graph to get to table, it's telling you for sure you can't have any negatives. And then you start at the spot 0, 0. And then I have 1, 1. When you are graphing this, you should have tried to put as many nice points. So notice the points that I'm using so that you can have a nice curve. So 9, 3. So that this should have a curve. Notice I'm not going to go past this. If you draw a line right here, that would be marked wrong. So my parent function, I'm going to go over the domain and the range here. Domain, range. So my domain is my x value. So this point right here will help you with your domain and range. This point right here. I sometimes make that into owl. I'm not going to make that into owl today. Maybe I will later. So right here, this is how far left I will go. So x will never get negative. So x is going to be greater than or equal to 0 because it's moving over here. My graph is going over here. My range is my y value. Y is never going to go below here, that 0 here. So y is greater than or equal to 0. Now we're going to talk about transformations. This is where we start from. The A, H, and K are going to be the same type of transformations that you've been dealing with other graphs that you've seen. So this A, if it was going to be greater than 1, it will stretch it out. It would make it go like, ooh. If this was less than 1, it's going to make it skinnier. It would be like, beep. If this was a negative, if this was a negative number, it would flip it and make it go like this. The H moves it left and right, just like how other graphs we've dealt with. Remember, H is always opposite. So if this said -1, that would actually move to the right one. If it said +7, it actually moves to the left 7. This number moves it up and down. So if it says +4, it would go up 4. If it said -9, it would go down 9. So this is basically the same thing that I just verbally told you, this chart. Now, if I'm going to graph this, first thing I'm going to do is state my transformation. This transformation right there is going to be a flip over the x-axis. And it's good to have that so you kind of know where I'm starting from. So if I go into my y equals, this is the negative key. If you don't push the negative key, you're not going to be typing it in correctly. Second x squared x. So again, you can look at the graph, but you should, so you can kind of know what your graph should look like. If you typed it incorrectly, you have to make sure to type it incorrectly. I'm going to go to my table and look at have errors over there. So that means, again, I'm starting at this 0, 0. But now 1, -1, 4, -2, 9, -3. So again, I still should have this curve here. Now, I'm going to go over my domain and range. So the only difference between my parent function, this is this flip. My domain, this value, this point that I start at, that you might want to see my owl. So this point that I start at, the x value should always be matching this x value over here. This y value always should match this y value here. Then you have to decide what should go here. So domain is always x. X is getting larger. It's pointing to the right, so x is greater than or equal to. Here, y is going down. It's getting smaller, 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 so that means y is less than or equal to. So that would be my domain and range. And that's my owl. I don't know. So what if I have a k value right here? So this is where you have to be careful when you plug into your calculator. So I'm going to clear that out. I have second x. This right here, if you do not push the arrow over and then subtract 2, notice how that is not underneath my line, then you're not going to get the right numbers. So this is going to move down 2. So if you push graph, sometimes you can visually see, okay, this is what my graph should look like. If I go to my table, plug in these numbers, my first number is 0, -2. Next number is 1, -1. I have 4, 0, and 9, 1. So again, do not go past that first point. My transformation, it moved down 2 because of this 2 right here. My range is always with my x. At this point, this is 0, -2. So my x value is 0. My y value is -2. So x is moving to the right. X is getting larger, moving to the right. So x is greater than or equal to, because it's saying what numbers can x be. Here, my y is moving up because my graph is going up. So y is greater than or equal to. I want you to try to do this one by yourself. So you're moving up 1. It's up. Your transformation is up 1 because it's not inside of that root. So it moves up 1. Domain, x is greater than or equal to 0. Range, y is greater than or equal to 1. What if we have something inside the root? So this is like my h value from the beginning. So when I type this into my calculator, I'm going to go second y equals, actually let me clear this out, second x squared, and then x, this time I do not move it underneath. So notice that line should be there. So again, you could graph so you can kind of see what it is, but I do need exact points. So remember that when you have the h value, that's always opposite. So I'm actually moving to the left 4. This is moving left 4. So -4, 0, -3, 1, 0, 2. And we typically have one more nice number, 5, 3. So this is my new graph. So this point right here is -4, 0. So my transformation, I moved left 4. My domain is always my x, range is always y. It's matching these two numbers where it's starting from. So again, x is moving to positive, so x is greater than or equal to -4 because that's that first point we start from. Y would be greater than or equal to 0 because it's going up, 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 up. And again, that's the first point we start from. Try to do the next one by yourself. Moving to the right, 1. So now x is going to be greater than 1, y is greater than 0. So now what if I have an a value? My a value, again, plug it in. I'm going to clear that out. 2 second x squared gives me the square root x. Go to my table. I'm going to plot these points. I got a little happy. I kind of solved the whole thing. Sorry about that. Plot my points. Look at how now this 2 stretch of 2. I don't know why I wrote 3. This is a stretch of 2. So it's stretching it out. Still, x is greater than because it's getting positive. X is moving to the right. It's moving positive. Y is also greater than because it's moving up. I want you to try to do this next one by yourself. There's actually 2 transformations here. So at this spot, there should be 2 transformations. So I have a reflective of the x-axis pointing down. It's also stretching because of that 3. So it's stretched out. So it's not like that, like just when you have the negative. X is still greater than because it's still moving to the right. So my domain is any x value that's positive. Y is less than because when I'm talking about y, it's up and down. My graph is going down, down, down. So y is less than 0 because that's my starting point. That point is always where I start from. Now what if I have a whole bunch of stuff? So first, I plug into my calculator. Y equals, so I'm going to put a negative. So again, this negative key down here. And I have my 2 second square root. And then x minus 3, I have to make sure to arrow over. Now, before I actually show the graph, I can verbally tell you, this right here is going to reflect over the x-axis. This will give me a stretch. This is going to move right 3. This is going to move up 1. So I want you to try to plot the points. You should always be able to check your graph. The graph that you draw should look somewhat like this graph, and it does. Now I'm going to deal with my domain and range. This point right here, which is a 3, 1, that's the point I'm using for my domain and range. So x is with 3, that's my domain. My range is with the 1. Again, it moved to right 3, up 1. So you should also be able to find that point from your equation. X is moving to the positive because it's moving right, so x is greater than or equal to. Y is moving down, so it's less than or equal to. Why don't you try to do B by yourself? So if I push graph, again, your graph should kind of look like this graph. It's a little bit different because these are a little bit closer together. My x value is based on this point. So x is moving positively, so because it's moving to the right, so x is greater than or equal to. Y is moving up, so y is greater than or equal to. Again, this is your starting point. Cubic functions are different. So this left 1 down 4 stretches the same. However, when I actually just graph the cubic function, so I'm going to go to math, right here, cubic x. I'm going to put that in. I'm also going to put my transformation. So math, and then go down to the cubic root, and then this will be x plus 1. So you can kind of see what the parent function is. Now when I push graph, you'll see what the parent function is, and then it's also going to have my transformation. This is what the parent function is of the cubic root of x. This is what the parent function looks like, and this is our transformation. So when we're talking about left 1, down 4, it's this point right here where it kind of switches from going to the right with to the left. It has this like little squiggle. So this moved left 1, down 4, that point. The 2 stretched it out, so this kind of looks like it got stretched out more. So one thing that when we're looking at my domain arrangement, so I'm going to go to my table. Again, this moved left 1, down 4. So that's these numbers right here in the red. So I'm going to plot these numbers, left 1, down 4. If I go up, what's a nice number? -8, -2. Sorry. Okay, now I got it better. So now I was deleted that one so it's easier for me to see the points. So this is the point right here that moved left 1, down 4. So now on the right hand side, it kind of works to the right. On the left hand side, it curves to the left. So my transformation here is a stretch of 2. It moved to the left 1, down 4. My domain and range here, because my domain is my x value, it's going all the way to the left, all the way to the right. This is going to be all real numbers. That's the sign for all real numbers. It can also go like this, all real numbers, or all real numbers. You can do either one. For my range, I'm going down forever. I'm also going up forever. So there's nothing that's not included. So all real numbers. Why is that? Because you can take the cubic root of negatives. You cannot take the square root of negatives. You can take the cubic root. For B, I'm going to have you do this by yourself, but before you do, you should rewrite this. So this -1/2, that's going to flip and shrink my cubic root. The x minus 2 is going to move it right to, and I'm going to put the +3 because normally we have the +3 at the end. So this still moves it up and down. So I want you to try to do this one by yourself. So this is not supposed to look like a straight line. It should have a curve, but because of that 1/2 right there, because of this 1/2, it makes it really skinny. So you could plug it into your calculator and graph it too. It should be kind of have a little curve like that. But still all real numbers and all real numbers. And there we go. Graphing at its finest. Have a great day.